let's get this going. And for the ones that just join us, hello again. Thanks for joining us. And again, this event is Node.js Virtual Machine, developing an external plugin system within your web app. And it's part of the Developer Growth Summit 2022. I want to give you some quick instructions. We're using Zoom webinar, and it is completely normal that you can't see other attendees, but many of you are present. So please feel free to interact in the chat box. Make sure to set the chat to send to everyone since it defaults to hosts and panelists. You will also see a Q&A feature in the toolbar that it's down here. And this is where you can ask questions during the talk, and you can also upvote and comment on other people's questions. Our speaker today will get to your questions at the end. Last but not least, I strongly encourage you to follow our code of conduct so we can all have a good experience. And the link to it, it's also in the chat. Now, I want to introduce our speaker today, Douglas Gubert. Douglas, he is the tech lead at Rocket.Chat, and when he's not coding and worrying about developer experience and code semantics, he's studying languages or playing video games with his kid. And well, without further ado, Douglas, the floor is all yours.
Thank you, Gina. Hello, everybody. Good afternoon, good evening, good morning, wherever you are. And let's go. I'm just gonna share my screen now.
And let me spotlight the speaker for today.
Well, I don't get much feedback, but is the screen already visible?
Yeah, looks good.
Okay, awesome. All right, so at Rocket.Chat, we were presented a few years back with this challenge of enabling a plugin ecosystem to enrich the core experience of our open source product. And we had to approach it in a bit of an unconventional way due to how our product is used. So being an open source project, people can spin up Rocket.Chat servers in their self-managed environment. And for those, we still wanted to provide these workspaces with our plugins, which we call Rocket.Chat apps. So in this talk, we're going to go over some pieces we needed to put in place in order to this plugin system to work. And we're going to focus on the core element of it, which is the Node.js VM module. So a quick overview of what we're going to talk about today. We're going to go over why external plugins, why we went with it, and why you would be able to do that in your product as well. The environment requirements to run a plugin system like this, the Node module, the Node.js VM module itself, the structure of a plugin, and how to interact with the plugin. And after that, we're going to go over some of the caveats we found along the way of going with this approach. Right, so why having external plugins at all? Well, firstly, having support for plugins will allow third parties, partners, other projects in general to integrate with their products with yours, and thus improving the experience of both of them, hopefully. You will, of course, need to integrate with other applications by yourself first, but having this possibility is already half of the way. Next, plugins will foster your community, engaging them more deeply with your product or project. And this is even paramount for an open source project. In our case, it also streamlined the community management process, as now people who wanted new features They don't need to come up with a PR following our rules and our styles for code, and even potentially getting rejected because it doesn't fit what we envision for the project. And now instead they can develop a plugin for this purpose, which is much easier than diving into a humongous project to get a grasp of what's going on. Then having support for plugins will also enable the creation of a marketplace to distribute them, which leads to potential monetization strategy for your product. This again resonates a lot with open source as projects are constantly trying to get into a financially healthy state, right? But it's of course meaningful for non-open source products as well. And finally, plugins are cool. I mean, as a developer, being able to extend and enhance my experience in applications that I use and love, that's simply awesome, right? So with that covered, let's take a look at the characteristics of the approach we're taking here. So the environment requirements. Generally speaking, we have mainly two approaches to developing a plugin system. First, we could have simply a set of APIs over HTTP with some webhooks and call it a day. A very important component of this plugin system would be the internet, right? So as it is the means through which your app and the plugin, which is really just another application hosted somewhere else, that's how they will communicate with each other. But remember, the scope I mentioned earlier, it does include self-hosted and potentially air-gapped installations of an open source application / product. And this brings us to the unconventional approach of the introduction. We'll need to host the plugin within our own web application, server-side, in order to provide the extended functionality to our users at any time within their network. Here it is. So this architecture, it presents us with a situation that is arguably one of the most feared in the industry, running third-party and thus untrusted code inside your server. This means that all kinds of management of the environment in which the plugins will run, the plugin system per se, is going to be inside your core application. And then it will provide the means for this plugin to communicate with the business logic of the application. One thing to note is that both these approaches, they have a common fact in between them. That is that we will need to specify and implement a public contract, right? So your API itself with known methods and parameters that the plugin will need to interact with your application. These are, of course, very much tied to how the application itself works and what is the business logic and the core and how it handles stuff internally. So this is something that we're not going to be covering here. So for this to succeed, at the base of this plugin system, we need a tool that will provide us with a sandboxed environment isolated from the host application and other plugins as well, and that will restrict the scope accessible to the plugin, providing access only to the feature set we want to allow it to access. And here enters the Node.js VM module. So here's what this module does. And this part, I literally just copied it from Node.js documentation. The VM module enables compiling and running code within V8 virtual machine contexts. JavaScript code can be compiled and run immediately, or compiled, saved, and run later. And the invoking code provides a context, which is treated as the global variable of the invoked code. Let's explore there with code, shall we? This again, it comes from the documentation. So in this example, we can see that the external code here on line 8, it would be this simple sum here that we can see, and the definition of a variable. This is compiled and ran at the same time here on line 11 by using this running context function inside the VM module. The isolation, then, it happens by contextifying an object, which is something we see here on line 6 by using the create context method from the VM itself. So this modifies the object, and then you can use it as the context for an execution of code inside the VM. We can also observe here on the console logs that context.x will be 42, since the context here, we already provided an initial value to x and then added 40 to it. And context.y is going to be 17, as it is just defined here. But on the outer scope, we see here our constant x, it's going to still be 1, and y is not defined on the global scope. So here is the illustration of this isolation. Pretty straightforward, right? Let's keep going. Right, so from that example, we discovered that what we need to run our plugins code is the code itself, and a properly built context object. This context object is what we're going to use to make the dependencies visible and available to the plugin. And these dependencies are going to be what the plugin uses to communicate with the outside world in a controlled manner. These dependencies, they will heavily depend on your application as well. But they can be anything, like from a repository object that allows the plugin to interact with your user entities in the database, or a logger object that is customized to your application, or even a package, npm package that you want to make available, like Lodash, datefns, Lambda, these kinds of things. Now we're almost getting to a real world view of that VM module in action. But for that to make sense, we need to talk first about what we expect out of our plugin. Just a sec. Right. So here is the structure of a plugin. The plugin can take many shapes, of course, and that will affect how you handle it inside your application. In our framework, we expect the plugin to be a JavaScript class that implements a set of methods as per our definition. Here, TypeScript helps us a lot by making these contracts more visible and discoverable in the form of interfaces and abstract classes. But TypeScript itself is not required for the concept to work. So now let's check a valid example of a plugin as it is expected by our framework. So this it ain't much, but it's honest work. This is a minimalistic hello world style example. It does nothing more than just logging a message to the terminal upon construction. But the important bits to take note here are, first of all, export class and then scaffolded app. This is going to be what the host system will see The part where it extends app, this app is a class we provided inside our framework, and it will be helpful for us to later determine whether a plugin is really an instance of the app that we want it to be. And lastly, the parameters that we are receiving in the constructor. So these are the dependencies that we've just talked about, and they're all objects, and they're going to be used later on by the plugin. Right, so now we already know what to expect from the plugin in our example. So how do we get it to work? I'm going to show you how our plugin framework does that. Here you can see, and Gina, if there is, if it's not readable, please just let me know. But if it's okay, we can just keep going. This here is the function that turns the plugin's code into an executable object. I've extracted it from our repository on GitHub and slightly just modified and omitted some parts of the code just so that it is easier for us to observe what we want. You can also notice some type definition in the function's parameters, but as we are using TypeScript, but they're not that important here. We'll discuss what's necessary, but we're not going to deep dive into them. Let's just focus on the more interesting parts. Here's the first one. Here you'll see we're using the VM API slightly differently. Slightly differently from the example we saw before, as we'll be first compiling the code and then executing it later. On line 12 here, sorry, line 11 here, we are instantiating a new script, and we send to this script as a argument, we send it the content of the file of this plugin, which in our case was that small class we just saw before, which is the scaffolded app. The code is inside this files variable, which is a key value structure containing file names and the content. But there we don't need to go in further detail on these guys. Just what we need is the VM script and the content of the plugin that we want to execute. And now we have an instance of this VM script with the plugin compiled in it. Now the plugin has just been compiled and the code interpreted, but not has been executed yet. It has merely been compiled down. Then on the next line, here on line 12, that's where we run it by calling this running context function on our script object. And this does run the declaration of the class, which is the only thing we have put in the contents of the file before. And the assignment of that class as the export of that module. And if we look at line 9, we can see we're building a context. Remember, this is going to be the global scope that the VM will expose to the plugin. And it is made of a require function that overwrites the default one. This prevents the plugin from using our default require function to get dependencies or modules like the OS module, file system module, things that we really do not want the plugins to meddle with. We have also an exports object, and this was for us to receive whatever that module is going to export, which in our case is our class. A mock process object, again, this is something that we do not want the plugins to mess with. We don't want it to go shutting down our process or grabbing information about the environment. And finally, the console, which is the same console we all know and love from our everyday work. So now back on line 12, the result we get from the running context call is the result of whatever was evaluated in the last line of the script it received. So in our case, this is the declaration of that scaffolded app class. Moving forward, the next interesting block we want to check here is where we make another call to the VM API. And now we really instantiate the plugin and provide the dependencies needed for the code to run. Notice here on line 21 that the external code or the script that this VM is going to run is fixed. We built the code on a certain way. So it is technically, this bit is not a third-party code that is being executed, but instead something we're just passing here. But all these names, the app, info, RC logger, and app accessors, those are not known to the VM or the V8 runtime. So those names are something that are things that we're going to have to put in the context. And we do so by assigning the values here in the context object. Those are mainly the dependencies we've talked before. Again, we override the process here. The result, the app, which we're going to instantiate here, is the same result we got previously with the declaration of the class. Info here is just a key value map with meta information about the plugin itself. The app accessors holds the dependencies which this plugin will use to interact with the host system, with the outside world. And the logger is one of our loggers just wrapped in a different object. And this here is the moment where the object of the scaffolded app class is instantiated and where the hello world will be logged to the terminal. This new instance is then returned and assigned to this app instance constant we have here. An important thing to mention here is that whenever our application wants to initialize and interact with the plugin, it needs to have its code available. So that means one of the most important parts of a fully fledged plugin system is a system that will persist that code somehow so that it is available during the application startup. This will be needed whenever your application restarts or in some other strategies, like with Docker containers, you will most likely, when you update the application, you're going to start it all over. So this code of the plugins, they have to be persisted somewhere in the database in a file system for you to fetch and interpret later. But this is a topic that deserves a talk of its own, and since we're focusing here on the VM module, we're not going to be covering that part. All right, what we've done so far. So given a plugin's code, we got an instance of that code. This instance allows us to interact with the plugin's methods. We didn't provide many methods for now, but that's what it allows us to do. This instance is isolated from the rest of the application, and it can only interact with the host application via the objects we've passed through the context. So it seems that our requirement from earlier, they have been covered. It is isolated. It is a sandboxed environment. Hooray. Now let's interact with the plugin. Right. For that, we need to modify our class a little bit and add a new method here, which is called onEnable. It is just as minimalistic as the constructor, and the definition follows the same one we have in our framework. So that's why it's a sync and it has some parameters and it returns value, but those are all details that are there to satisfy the contract. Now, say we want to call this onEnabled method from the application. What we need to do is the following. And this is an example that hasn't been taken directly from our framework, but it still illustrates the idea of how we interact with the plugin. At this point, it's more straightforward, I'd say. We call this running new context function, passing to it the actual method call that will be executed inside this new context as a string here. And the global context that will be available for it as a second parameter. We use an await for the call here. So if the plugin returns a promise, we most likely want to grab the resolved value instead of the promise itself, right? The try catch block here also prevents the application from crashing in case of a runtime error. And if the error does occur, we go here, we panic, and we just log it, or we can add some logic here to retry the call, notify the plugin's developer, or take any other kind of action. Now, the code that we're passing here for the VM, again, is constructed by ourselves. We have to pass then the names that are not known by the V8 runtime, in this case, app and args. You can see that method here is interpolated, so this is going to be evaluated as app.onEnable via our const here. And then we just apply the arguments that we have constructed here. This is our mock dependencies that will allow the plugin to interact with the outside world. And this is it. Plugin interaction success. Voila. Now we have interacted with the plugin and made it to extend the functionality of your application. What we can do now. So now that you can interact with the plugins, what is possible is really only limited by your creativity or potentially vetoes from the business and well, whatever APIs you have offered so far. So you can provide APIs that will allow the plugin to hook into your application's events. It will, or you can provide APIs that will allow it to register as an endpoint, an HTTP endpoint, similar to webhooks. You can allow it to schedule jobs to be run. Those you will probably need some other library or some other way of controlling these schedulers, but providing it to the plugin already helps a lot. And allow it to send notifications to your users via email, via push notifications, anything really. So whatever you provide it with APIs is going to be possible. Keep in mind though, that you really want to control what is feasible or not. Otherwise, like, it's going to be really hard to debug problems when they come, and they certainly will. So now, caveats of this approach. First one that is really got us, it's difficult to allow plugins to include NPM packages. Sure, you can allow them to use the packages you have already available in your application. But for the plugin to be able to do that, to add packages by itself, you have two options. Either you access the plugin's package JSON file and install those packages at runtime, which I dare say it's impossible or at least close to. Or the plugin has to include the code of these packages bundled within its own code. And this is actually what we have adopted to solve the problem, as we have a CLI tool that will bundle the packages and the plugins code together for Rocket.Chat server to execute this code. Next, we can see that promises can escape the flow of the invoking code. And this is because even though the context that the VM creates is isolated, the code run by the VM shares the same event loop with the rest of the application. Here, the then function of the promise schedules what is called a micro task, which is run right after the current execution of in the event loop queue. This causes the function here, like running new context, to return before any functions from the then chain of promises is called. So it basically just escapes the flow in that way. But it does not escape the VM context itself. The function will still not be able to see anything global that hasn't been passed to it. It's just the flow that is going to be potentially a bit weird to wrap your head around. But the same context, the same sandbox is going to be there constraining the access for the plugin. Finally, and here I quote the Node.js doc again, the VM module is not a security mechanism, so do not use it to run untrusted code. Okay, but like in our defense, this wasn't as prominent in the docs back in the day as it is now. But yeah, if the code has some clever prototype chain walking, it can essentially jailbreak the VM context, unfortunately. I'm obviously not going to show this exploit here, but the way we worked around this was by introducing a review process in our marketplace. So before the app is actually distributed to our users, we have a review process that is aimed to identify any potentially malicious piece of code that the publishers might have put in. Of course, this is a process that does not scale that well. We have our engineers doing the review, so it's not the best approach. And we're already looking into the alternatives to be implemented, like static code analysis tools, or even separating the plugin system into its own process instead of running along with the process of the main product, so that we can achieve like true isolation. But there's nothing set in stone yet. Those are the alternatives that we are exploring right now. And folks, that will be it. There you have it. I hope this gave you some insight into implementing this plugin system in your web application. We haven't covered every single aspect required to achieving this fully fledged system, but this is like the backbone of the thing, and it will allow you to iterate and improve the system as you go. Thank you very much. Thank you for being here. Hope you enjoyed it. I think just a quick last announcement that we are hiring. So check out the link for open positions and come join the world's largest open source communication platform. That's it.
Thanks so much for that insightful talk, Douglas. And I feel like a lot of the developers joining today would love to join your team. So now you know there are the links so you can apply. Yeah, so this was a great talk for anyone who's interested in learning how to use the virtual machine model. But right now we have time for questions, and some of the attendees have already been adding some great questions in the Q&A box. So please feel free to keep adding them. Douglas would be so happy to keep answering them. And let's jump right in. Okay, so Mina is asking, in the context of the environment requirements slide, what do you mean by an air-gapped installation?
Oh, sure. Just let me go there. Oh, it's not mentioned. Anyways, an air-gapped installation for self-managed servers is when the server itself does not has access to the internet, only to the private network of the whatever organization is running it. So essentially, like no external service can be accessed by the application, only internal services. This is why the previous approach would not work, since your app here in the web server would not have connection to the internet, and would make this communication with a plugin, with an extensible plugin, impossible, right? So that's why we went with the second approach.
That makes total sense. Thanks, Douglas. Yeah, Mina has another question that I would love to answer. Could you show an example of a Docker container compose where you provide the plugin code to the sandbox environment?
I don't have anything like that at hand, unfortunately. I can tell you how we do it. We actually we store the code. So we package these code into small zip files, and then our application, the Rocket.Chat server, it downloads this app and this package from our marketplace, and then it interprets the source code, right? So the code of the plugin itself. So and then with that code in hand, we actually store it in the Rocket.Chat's database, so that it is always there when Rocket.Chat is restarted. It tends to happen quite a bit. So that's something we really looked out for. Hopefully it answers your question.
Thanks, Douglas. Anyways, if any of the attendees here have follow-up questions to Douglas' replies, please feel free to keep adding them so we can discuss a little bit more about that. I'm reading a question from Daphne, and she's asking, for developers who want to get started in virtual machine models, any specific projects they could get started with?
A Rocket.Chat app. But I think this will not be something that we will commonly find in the scope of a business application. But I could suggest really our framework as a source of how you interact with this VM module itself. I am not aware of many of other applications that do that with JavaScript, right? So on the Node.js ecosystem. So yeah, I guess that's my answer. Check us out on GitHub.
Great. Okay, we have one more question from V. And V is asking, does Rocket.Chat have a front-end plugin system? Have you explored that in addition to the backend?
That's an awesome question. We do have a way. It's not like we us sending app code to the front end, but the approach we went with was we have like this library which we call UI kit, and this UI kit we define a lot of blocks, a lot of visual elements that the app can use to, for instance, enrich a message or open a modal for a user with a form where the user can input some data and interact with some other visual elements in the Rocket.Chat platform. If you have used Slack, you might have seen something familiar with their Slack apps. But yeah, like we have this part in place. It doesn't cover all of the capabilities of the front end, but it really allows plugins to have a powerful and secure interaction with our users and with the browser.
Perfect. Thank you so much, Douglas. I think because of the time, we're going to wrap up the event here. And if we didn't get to your question or you still want to ask something, please feel free to reach out to Douglas after the talk. But before we officially end the talk, Douglas, do you have any final thoughts or encouragement tips that you'd like to give everyone here?
I don't think so. Sorry, I'm missing words for that. But I think a good tip would be apply. we're hiring. Follow the link.
That's a great tip. Sounds like a Rocket.Chat is a good place to learn and just like keep growing your career as a developer. So remember, everyone, go apply. Well, thank you all so much for joining. A quick reminder that we have a swag giveaway going. So don't forget to use the hashtag DGS2022 in your social posts to increase your chance to win. And we encourage you to share any learnings or questions from this session on social. And just be sure to tag us and use the hashtag. Again, hashtag DGS2022. We will be picking some of you to send us swag to. Also, if you'd like to be a speaker of your own event in the future and share your experience with fellow devs, just as Douglas did with us today, please check out the Codementor Events homepage. All the links are in the chat right now. And as you know, there will be more events coming up after this. This webinar room will be open for another 5 minutes with some information showing, but after that, we will close the room until the next event starts. Check out the link in the chat. And the slide here for information of the next event. Yeah, so please feel free to stay and chat for a few minutes. And if you do share anything on social, be sure to tag both Douglas and Codementor. Follow Douglas in his social media and apply to Rocket.Chat. And thanks so much for joining.